Hello everybody, welcome back to Math 245. I hope you're having a wonderful day. Today we are focusing on how to solve a system of linear equations through a method that we call addition. So here's how we solve a system of linear equations using addition. We have these 7 steps that will help us through this process. Our first step is to write both equations with the variable on the left side of the equal sign and the constants on the right. So let's look at this example right here to see if this first step is already taken care of for us. We want to write both equations with the variables on the left side of the equal sign and the constants, or the numbers, the constant, that just means numbers, on the right side. Well, in this case, we are good to go. We already have our equations set up like this, so step 1 is complete. Our second step is to write the equations one on top of the other so that the variables line up. So I want x and x to be on top of each other like they are here. And I want y and y to line up on top of each other here. So this is also good in this example. So step 2 is taken care of. Now our goal is eventually to get our coefficients, or the numbers in front of the variables. We want one of them, either x or y, to be the same number but with opposite signs. So that is our goal. We are going to be multiplying one of the equations by a number. That is step 3. In this case, I have x and 3x in my x values. So I want to multiply this top equation by -3. If I multiply the top equation by -3, then I will have -3x on the top equation and 3x on the bottom equation. That is exactly what I want. I want the same number but different signs. So if I multiply the top equation, all of it, both sides, by -3, I get -3x minus 9y is equal to, and then -14 times -3 is 42. And then I leave the bottom equation as is because I have a positive 3x there. So I'm just going to leave this as is. So I have 3x plus 5y is equal to -18. That is step 3 of this process. Step 4 is adding these equations together. Now the reason that I wanted the x values to have a -3 and a positive 3 in front of them is so that when I add these two equations together, they cancel out, and I'm just left with the y values. So when I add these two equations together, I get -3x plus 3x, which is just 0x. -9y plus 5y is minus 4y. And then I have to add the constants together as well. So 42 minus 18 is 24. So that is step 4. I added the equations together. Next, I solve this resulting equation for the variable that remains. In this case, our remaining variable is y. So I'm going to solve this for y by dividing both sides by -4, which gives me y is equal to -6. That was step 5. After I have this first variable, I next need to solve for my other variable. So I have 1/2 of my solution. I have the y value, but now I need to solve for the x value as well. So I'm going to take this solution and I'm going to plug it into either one of the original equations to solve for x. So I'm going to use the first equation. My first equation said x plus 3y equals -14. This gives me x plus 3, and then I can plug in the y value that I just found. Y is equal to -6 equals -14. So I have x minus 18 equals -14. If I add 18 to both sides, I get x is equal to 4. So this is the second half of my solution. So I have found that the solution is 4, -6. So this is what we just did here. This was step 6 above. My last step is to plug the solution into both of my original equations to check my work. So I will do that now. I'm going to plug in these two numbers into the first equation. So the first one was x plus 3y equals negative 14. That gives me 4 plus 3 times negative 6 equals negative 14, or 4 minus 18 equals negative 14, which is true. And then I need to check the other one as well. So I have 3x plus 5y equals negative 18. That is 3 times 4 plus 5 times negative 6 equals negative 18, or 12 minus 30 equals negative 18, also true. So now that we have done this last step, step 7, we know that we have the correct answer. So we are good to go. Okay, before we solve the next example together, I would like for you to pause this video and try to do this example on your own. So go ahead and give this a pause, and using the steps that we just did above, give it a try. All right, hopefully you have paused it and given this one a try. So now let's do it together so that we can check our work. So our first step, like we did above, is to make sure that we have all of the variables and coefficients on one side of both of the equations and the constants on the other. So in this case, we're good to go. Next, I need to make sure that my x's and y's are lined up. In this case, they are, so we don't need to do anything there. But now I want to make one of my coefficients the same number, but negative. In this case, I could either do x or y. Both of these are pretty easy. But I'm going to multiply the top equation by negative 2 to make the number in front of the x a positive 6. It's okay if you did it differently. There are more than one ways to do this. So I'm going to multiply the top equation by negative 2. Again, it's all right if you did it a different way. So when I do that, I get negative 2 times negative 3x gives me 6x plus 8y equals positive 4. And then I leave my second equation alone to get negative 6x minus y equals negative 11. Now that I have this, I can add them both together. And of course, one of my variables should cancel out. If that doesn't happen, that's a good sign that maybe you need to go back and recheck your work. So my x's cancel out. I'm left with 0x. And then I have 8y minus y, which gives me 7y, is equal to 4 minus 11 is negative 7. Oops, it's negative 7. So dividing by 7 gives me y equals negative 1. Now to solve for my x value, I am going to plug this y value into either one of the original equations. So I'm going to plug it into the first equation. You could do either one. So this is going to give me negative 3x minus 4 times our y value, which we found to be negative 1, equals negative 2. So I have negative 3x plus 4 equals negative 2. Subtracting 4 from both sides gives me negative 3x is equal to negative 6. And then I divide both sides by negative 3 to give me x equals 2. So my proposed solution is 2, negative 1. So let's go ahead and check our answers to make sure that we are good to go. Oops. I'm going to plug our solution into both of the original equations. So I have negative 3, what was our equation? Negative 3x minus 4y equals negative 2. So plugging in x equals 2 and y equals negative 1 gives me negative 3 times 2 minus 4 times negative 1 equals negative 2. That is negative 6 plus 4 equals -2, which is true. So our first equation is good. Next, we need to plug into the second equation. This will be -6x minus y equals -11, or -6 times 2 minus -1 is equal to -11. That is -12 plus 1 equals -11, also true. So we are good to go. We have solved this one correctly. Our last equation, system of equations, looks like this. And we're going to have to do something tricky on this one. So first things first, we need to make sure that our coefficients and variables are on one side and our numbers are on the other side. In this case, that is true. And our variables are lined up with each other. However, there's no easy way to multiply one of the equations in order to get one of the coefficients the same number but negative. I can't multiply 5x or 5y by any constant, any easy number, to make them opposites of 4x and 8y. So in this case, I'm going to be multiplying both of the equations by a number. So there are multiple correct ways to do this, but this is one correct way to do this. So maybe let me make a note. More than one way. One correct way to solve this equation. But here is one way to do it. I want the x's to have a 20 and a -20 in front of them. So here's what I'm going to do. I'm going to multiply the top equation by -4, which will make our coefficient in front of the x -20. And I'm going to multiply the bottom equation by +5, which will make the coefficient in front of that x +20. So by doing this, I will have the same number in front of the x, 20, but on the top I'll have -20, and on the bottom I will have +20. So when I do that, the top equation becomes -20x minus 20y is equal to +80. Multiplying everything on the top equation through by -4. And when I multiply the bottom equation through by 5, I get 20x plus 40y is equal to 20. Now, I see that one of my variables, in this case x, will cancel out. That's a good thing. When I add these two equations together, I get 0x, -20y plus 40y is plus 20y is equal to 100. So then when I divide both sides by 20, I get y is equal to 5. Now I'm going to be plugging in y equals 5 into one of my original equations. Let's do the second one. So when I plug y equals 5 into the second equation, I get 4x plus 8 times our y value, which is 5, equals 4. So I have 4x plus 40 equals 4. If I subtract 40 from both sides, I get 4x is equal to -36. And dividing both sides by 4 gives me x equals -9. So my proposed solution is -9, 5. And finally, we need to plug in this solution into both of our equations to check our work. Our first equation was 5x plus 5y equals -20. So I'll have 5 times -9 plus 5 times 5 equals -20. Well, this is negative 45 plus 25 equals negative 20, which is true. And my second equation was 4x plus 8y equals 4. That gives me 4 times negative 9 plus 8 times 5 equals 4. So I have negative 36 plus 40 equals 4, which is true. So these are our 3 examples for the day. I hope that you learned a lot today. I know I had fun teaching you this lesson. So please let me know if you have any questions about this on the discussion board, or send me an email. Next time we will be talking more about how to solve systems of linear equations. So be looking forward to that. I will see you on Friday. I hope you have a wonderful day.